At the end of the last video, we got a test statistic, and if you recall when we got a t or a z test statistic, right, we were almost done. We just had to calculate the p-value using the distribution and the command in Excel, like, norm.dis, t.dis, or t.dis.rt, or t.dis.2t, right? So what about a chi-square? Is there a command for that? Well, yes, but let me get there first. So the idea is that when we compute a different type of test statistic, it has a corresponding distribution, statistical, or yeah, probability distribution. And so consequently, when we change the type of test statistic, we change the distribution. And so I feel obligated to tell you a little bit about the distribution. And so here are some different pictures of what the chi-square distributions look like. You can see there are different ones, and there's this DF, and we've seen DF before. It is degrees of freedom, and we saw that from in the T distribution. And so you can see that as the degrees of freedom change, specifically as they increase, the shape of the chi-square distribution changes as well. Okay, so you can see degrees of freedom 1 in red, and then there's this brown thing, or maybe dark orange for degrees of freedom 2 and 3 and 5 and 10, right? And 10, you can start to see that kind of hump forming, right? But in any case, with degrees of freedom less than 10, right, there is a hump, and then there's this tail going off to the right. Remember, that's when we see that happening, we say that that's a right skewed distribution. Or skewed to the right. And so when we talk about a chi-square distribution, it does have a few different properties. First thing that I want to point out is if you look at the domain, or the horizontal axis, right, the domain is all positive numbers. And that makes sense because when we talk about the chi-squared test statistic, right, wasn't it, it was, when we computed it, it was, O minus E squared over E. And this value here, the numerator is positive, and then the denominator is positive. So the whole thing, you're just adding a bunch of positive numbers. So consequently, that's why, well, I should say positive, but I should say non-negative. So that makes sense that the domain is going to be all non-negative numbers. Okay, I mentioned that it's skewed to the right, and that is actually important because that's plays a large role in how we calculate the p-value. So since it is right skewed, the p-value, remember, is the probability of getting our result or anything more extreme. That means the direction of extreme is to the right, since we have a right skewed distribution. So we want area underneath the curve and to the right every single time for a chi-square test. Okay, and then as I mentioned before, there's degrees of freedom that are required. Okay, so calculating the p-value. Okay, it is area under the curve and to the right, and so that's why when we are in Excel, we need to use chi-sq. Don't say CHISC. Okay, it is chi-sq, chi-square dot dis dot rt, right, for the right side, and then do our test statistic, and then whatever the degrees of freedom are. Now, I haven't talked about how to determine that. That's actually just number of levels, or, in the case of eye color, it would be the number of different eye colors minus 1. Okay, so number of levels of the categorical variable, or variable, and then subtract 1. Okay, there is this other command, chi-sq.test, and all you need to do is highlight the observed and expected counts for that. And so that's useful if you don't need a test statistic. However, I'm going to tell you, I'm going to make you find the test statistic frequently. So know that that's available to you, but if you're asked to find the test statistic, you can't use that. Okay, so we're back in our example, and we've done all that hard work, right? We just want to calculate the p-value. So hopefully you have this saved. If not, you can just follow along. But I'm going to just kind of wrap this up and say, okay, well, we have our test statistic. That's the 25 number. Degrees of freedom here. That's going to be number of levels minus 1. So we have the levels of eye color are brown, blue, right? So there are 1, 2, 3, 4, 5, 6, 7 levels. So that means my degrees of freedom is 7 minus 1. 6, right? And then for the p-value, I'm going to do chi-sq.dis.rt. The x here is our test statistic, and degrees of freedom, 6. Okay, chi-sq.dis.rt, boom, done. Very, very small p-value, and I can check this using that other command, chi-sq.test, and then the observed would be this, the expected would be this, and Excel will do all the calculations in the background, and this is where I like to do this just to check my answer, and they match. Okay, and significance level here, we didn't define that, but I'm just going to say 0.05. Okay, so those are the only new mechanics. Otherwise, our conclusion is going to be the same. I'm not going to take the time to write it out here, but we know that P is less than alpha, so we reject the null. Okay, and we would go back and say, okay, if our hypotheses were these, we would say there is evidence that at least one eye color proportion does not match the stated value. Okay, so that, and otherwise you can say, you know, P is less than alpha, we reject the null, and there is sufficient evidence that this, and then you can go on and say any sources of error, okay, which we don't have any just yet. Okay, so we've done it for the eye color example. I want you to try finding the p-value concluding the test for the Gregor-Mendel example. Okay, resume the video when you have found a p-value and a conclusion. And here you go.